Greetings to all my fellow math nerds. Today we will explore the sophisticated approach of antidifferentiation by substitution, which enables us to decompose complex integrals and extract the original functions from their derivatives. This approach is an art form as well as a technique that, with practice, will unlock a wealth of calculus-related opportunities. Here we have the basic integration rule. The integration rules are rules used to integrate different types of functions. Here we have the different types of integration rules. We have the constant rule, the power rule, the constant multiple, and the sums and differences. Now that we know the basic integration rules, let us now proceed with our first example for U-substitution.
Hi guys, I'm Glaiza, and this is example number 1. With the given integral of 2x squared times x cubed plus 2 raised to 2 dx, first, we are going to let u be equal to x cubed plus 2, then we are going to get its derivative. The derivative of x cubed plus 2 is du over dx is equal 3x squared. Now, we are going to divide both sides by dx over 3x squared. On the left side, we have a common factor which is dx. On the right side, we also have a common factor which is 3x squared, so we are going to cancel that. Du over 3x squared is equal to dx. Now that we have the value of dx, we can now proceed with the substitution integral 2x squared times u raised to 2 du over 2x squared. As we can see here that we have a common factor which is 2x squared, so we are going to cancel 2x squared and we will be left with an integral of u raised to 2 du. Next, we are going to use one of the basic integration rules, which is the power rule. In the power rule, we are going to copy that, then add 1 to its exponent. So we are left with u raised to 2 plus 1, and we copy that and put it below, and we will replace du with plus c. As you can see, we are now left with u raised to 3 over 3 plus c. To get our final answer, we are going to substitute the u, so our final answer will be x cubed plus 2 raised to 3 over 3 plus c. And that is our final answer for example number 1. Now, Jared will explain example number 2.
To give an integral of 3x squared times x cubed plus 3 raised to 3 dx. The first step is to find the u value, where we just simply take the variables and constant inside the parentheses x cubed plus 3, then find the derivative of x cubed plus 3, which concludes to 3x squared, and write it down as du over dx equals to 3x squared, then divide the left side and right side. Dx over 3x squared, then cancel out similar variable and constant, which leaves us to du over 3x squared equals to dx. After that, we will just copy the given and replace the column as u. Integral of 3x squared times u raised to 3 du over 3x squared. Since we still have similar variable, we need to cancel those out, and that gives us only the integral of u raised to 3 du. Then add plus 1 to the exponent, and whatever the answer of the exponent plus 1 will be added as also the denominator of u. That gives us to u raised to 4 over 4, and change du as plus c. Distribute the value of u to the given, which gives us the integral of x cubed plus 3 raised to 4 over 4x plus c. That concludes as our final answer.
For example number 3, the given is integral of x to the 5th times x to the 6 plus 36 raised to 5 dx. First, we get the value of u, which is x to the 6 plus 36. Next, we derive. X to the 6 plus 36 derived is du over dx equals 6x to the 5th. Now, we will get the value of dx by dividing both sides by dx over 6x to the 5th. And we cancel the common variable and constant, which leaves us with du over 6x to the 5th equals dx. Now that we have the value of dx, we will just simply substitute the given. It will be written as the integral of x to the 5th times u raised to 5 du over 6x to the 5th. Next, we cancel the common variable and constant, and we will be left with the integral of u raised to 5 du over 6. Since we cannot proceed to the next step due to du over 6, we will just simply factor it out and move it to the other side. Now we multiply 1 over 6 to u raised to 6 over 6 plus c. And the answer would be u raised to 6 over 36 plus c. We can now substitute to get our final answer. And the final answer would be x to the 6 plus 36 raised to 6 over 36 plus c.
In example number 4, we have the given integral of 5x raised to the 4th times x raised to the 5th plus 2 raised to 9dx. The first step is to find the u value, which is any value inside the parentheses. Once we locate the value of u and find the derivative value of the given u, x raised to the 5th plus 2 derived becomes du over dx equals 5x raised to the 4th. Once we find the derivative value of the given u, we will then divide du over dx and 5x to dx over 5x to the 4th, and we will cancel the common constant and variables, which then concludes as du over 5x raised to 4 equals dx. After we find our dx, we will rewrite the given integral of 5x to the 4th times u raised to 9 du over 5x to the 4th. As observed, we can see that the given was changed inside the parentheses as u. Since we have 2 5x to the 4th, so we will cancel it for a more easy solve. That leaves us to the integral of u raised to 9 du, then we will add 1 to the exponent, and whatever the answer that results. It will value also as a denominator, leading us to u raised to 10 over 10 plus c. Since there is no further simplification in our given, we will distribute the value of u to our u as our final answer that would result as raised to the 5th plus 2 raised to 10 over 10 plus c.
Hi guys, I'm Iyah, and here is example number 5. The given is integral of x over the square root of x squared plus 6 dx. First, we convert the square root of x squared plus 6 to x squared plus 6 raised to 1 1/2. Next, we get the value of u, which is any value inside the parentheses. We will write it down as u equal x squared plus 6. Now we derive, so x squared plus 6 derived would be du over dx equals 2x. Next, we will divide it both sides by dx over 2x and cancel the common factor, and we will be left with du over 2x equals dx. Now that we have the value of dx, we will simply substitute the given, so it will be written as x over u raised to 1 1/2 du over 2x. Next, we will cancel the common factor, which is x, and we will factor out du over 2. Now that we factored it out, it will be written as 1/2 integral of u raised to 1/2 dx. Next, we use the power rule and we will just add 1 to our exponent and copy that and put it as our denominator. Now we simply multiply, so 1/2 times u raised to 3/2 times 2/3 plus c. The given 2/3 came from 3/2. We just reciprocal 3/2, so we had 2/3. So 1 times 2 is equal to 2, so 2 raised to 3/2 over 2 times 3 is equal to 6 plus c. As you can see, we can cancel 2 and 6 since here 6 is divisible by 2. So we would be left with u raised to 3/2 over 3 plus c. To get our final answer, we will just simply substitute it back. So our final answer would be x squared plus 6 raised to 3/2 over 3 plus c. Next, we have Xian to explain our final example, which is example number 6.
In example number 6, we have the given integral of x square root of 4x squared plus 2 dx. Now, we convert the square root of 4x squared plus 2 to 4x squared plus 2 raised to 1/2. Now, let u be equal to the value inside the parentheses. So u is equal to 4x squared plus 2. Now, we derive it and it will be written as du over dx equals 8x. Now, we divide it both sides by du over 8x. And we will cancel the common factors and will be left with du over 8x equals dx. We will substitute the given. So it will be written as integral of x times u raised to 1/2 du over 8x. As we can see here, we can cancel x. So we will be left with u raised to 1/2 du over 8. We will just simply factor it out. Now, we use the power rule by simply adding 1 to our exponent and copying the result as our denominator. Next is we multiply and replace du with plus c. So 1/8 times u raised to 3/2 plus 2/3 plus c would be equals to 2 times u raised to 3/2 over 24 plus c. As we can see, we can cancel 2 and 24. So we will be left with u raised to 3/2 over 12 plus c. To get our final answer, we will substitute u back. So our final answer would be 4x squared plus 2 raised to 3/2 over 12 plus c.
So there you have it, guys. We are finally done with our lessons, and I hope that you learned a lot about antidifferentiation by substitution. Don't forget to like and subscribe to our YouTube channel and turn on the post notifications so you will be updated on our next video.